So in this video I want to talk about two more number systems that you really need to know in logic design and digital electronics. And those number systems are octal and hexadecimal. And these two, so for octal, your base that you're working with is 8, and for hexadecimal, your base that you're working with is 16. And we'll find out that it's actually really easy once we convert to binary base 2, that it's very easy to quickly convert from base 2 to either base 8 or base 16. And let's run through that real quick. So if we have a number in base 10, I guess we can take our example from the last video, which was 18 base 10 equals 1 0 0 1 0 in base 2. And if we take this number and we want to go from base 2 to base 8, we actually convert. When you go from any other base other than base 8 and base 16, as we'll find out, if you're going from one base to another base that's not 10, you have to go to 10 as an intermediary. So we're already starting off. We already know what this number is in base 8, so we'll just start with 18, and then we'll do the same process as before for base 2, where we divide and take the remainder and keep dividing until the remainder is 0, or the quotient is 0. And so let's do that. So we'll take 18 in base 10, and we'll divide it by 8. And let's see, so 8 goes into 18 twice. And now this number is going to be our least significant digit, right? So the first number is always the digit to the right. So in this case it'll be in the ones place, or the 0 place. So now we have 2 in base 8. And now we take 2 and we divide 2 by 8, and 8 can't go into 2, so we say 0, and now we know it's to stop. Once we get a 0 up here, this means stop. And now our remainder is 2. So now we have 22 in base 8. Now let's see if this actually works out by converting back to decimal. So we learned last time that when you're converting back to decimal from any other base, we just use the base as our number, right? So in base 8, 8 would be 8 equals 1 0, right? In base 8. But when we're converting to decimal, we use 8, not 1 0, right? So we can take 2, this 2, and we multiply it by 8, and then we take the other 2, we add that, and we multiply it by 8. And let's see, so we start at 0, like I said, we start in the previous video, we start at 0 for this spot, 0, and then we add 1 for the next spot. So it'll be 8, and this just turns to 1, so it'll be 2 times 1 plus 2 times 8, which is 16, equals 18 in base 10. So we've confirmed that these are indeed correct. And now let's see. So let's see if we can find a pattern between this number and this number. So in base 2, 18 is 0. This right here is a pad. That's what we call padding. And that just means we finish off, we finish filling in the rest of the number with zeros, right? So we have 0, 1, 0, 0, 1, 0 in base 2, and we got 22 in base 8. So now the quick and easy way to convert from base 2 to base 8 is to take in groups of 3 and just convert it into its decimal equivalent. So here, the decimal equivalent of 0, 1, 0 would be 1 times 2 plus 0 times 2, and we start at 0 and then we add 1, so now we have 2 in base 10. So this group, this term actually equals 2, and this is the same, so this is base 2 also, or this is 2 also. And now now you see, okay, well, 2 and 2. And that's a quick and easy way to convert. And the same thing goes for hexadecimal. So instead of groups of 3, we actually take groups of 4. So we have 0, 0, 1, actually 3 zeros, 1, and then we have 0, 0, 1, 0. So this actually goes to 1, and this is 2. And this is our new number in hexadecimal. It should be 12, or 1, 2, 12 in base 16. And that's the quick and dirty way. It's actually not dirty, it's easy. It's quick and easy way to convert from decimal to octal and hex.